we will see about the correlation coefficient for discrete random variables and continuous random variables. First of all, what is correlation? If the two variables vary such that the change in one variable affects the change in other variable, this variable is said to be correlated. For example, there is some relationship between the height and weight of the person. It means if height increases, will the weight increase or decrease? So here we have two variables, height and weight. The difference between the variance between the height and weight is known as the correlation. Like correlation coefficient, it is the parameter which measures the strength and direction of the relationship between the two variables. Next, we will see about the types of correlation. It is positive and negative, simple, partial and multiple, linear and non-linear. Positive correlation means if the two variables deviate in the same direction. This speaks about the directions. So the two variables travel in the same direction means it is positive correlation, or it travels in the opposite direction means it is negative correlation. Simple and multiple correlation. Only two variables are considered for correlation analysis. It is called simple, for example, height and weight. If two or more variables are considered for correlation analysis, it is multiple correlation. In the study of relationship between the yielding of rice, both the amount of rainfall and usage of fertilizers are considered. Here we have three variables like yield of rice, rainfall amount, and usage of fertilizers. So it is a multiple correlation. Next, linear and non-linear correlation. The amount of change in one variable tends to clear the constant ratio of amount of change in other variable. That's called linear. If it changes dramatically, that means very large amount of changes means it is non-linear or curvilinear correlation. That means if rainfall is more than the production of rice, it would not necessarily be double the rate. In a practical case, it is not double. So it comes under the category of non-linear correlation. Next, these are the important properties. Always the correlation coefficient lies between -1 and +1. The two independent random variables are said to be independent means there is no dependent nature between two variables, so it is always uncorrelated. When x and y are independent, then covariance of x is always 0. And what is the correlation coefficient? It lies between -1 and +1. We know that positive correlation means it travels in the same direction. That means correlation coefficient is always greater than 0. And negative correlation means r less than 0. And no correlation means that correlation coefficient equal to 0. Next, we will see about the Pearson coefficient. It measures the strength of the linear relationship between the variables. Mainly, it have a linear relationship. So the correlation coefficient between two random variables given this formula, which is equivalent to covariance of x comma y divided by standard deviation of x into standard deviation of y. We know that covariance equal to expected value of xy minus expected value of x into expected value of y. Okay. Here in the x and y, these are the two random variables which varies from 1 to n. So this is bivariate distribution means it is a two-dimensional random variable. So sigma xy means we have to find the covariance of x comma y, that is equal to of xy minus v of x into y. Okay. Next thing, x bar means mean, right? Mean of x, that is summation of x divided by n. Y bar means the average value of y, that is equal to summation of y divided by 1. Sigma square, we know that is always equal to variance of x. Variance means z of xy minus z of x the whole square. Coming to the first problem, we have to find the joint probability. Mass function is given. We have to find the correlation coefficient of two-dimensional random variable x comma y. So this is the given random variables. So x varies from -1 and +1, and y varies from 0 and 1. So we have to calculate the correlation coefficient. Before calculating correlation coefficient, we need the values of x, expected value of x, expected value of x square, expected value of y, and expected value of y square. In that regard, we will find the probability values of x and y in this column. Okay, expected value of x means we know that formula summation x into px. So it is given here. Likewise, we have to calculate the value of expected value of x square. X square means we know that in between the summation, we have to multiply x square into p of x. Next, E of y was in form of summation y into v of y. Summation y squared means summation y squared into p of y. So this p of x, p of y represents the probability value of x and y, which is given in this last row and last column. Next, we will calculate the expected value of xy. This is equal to, this is a two-dimensional random variable, right? So double summation will come. So which is equal to double summation x and y into probability value of x comma y. So here we will take x value. This is x into y, right? So here we are taking x as 0 and y as -1. What is the probability value? 1 by x. We have multiple three things. Likewise, we have to proceed for all the four numbers. So the final answer is 0. Next, we have to calculate the variance of x and variance of y. Means we have to find the correlation coefficient, which is equal to covariance divided by sigma x into sigma y. Okay, covariance, this is the formula. We have to substitute all the known values in this formula. The correlation coefficient, which is equal to minus 0.258. So it lies between -1 and +1. Next problem, the joint probability function for two. Here this discrete random variables x and y is given by f of x comma y, where x and y can assume all the integers. So it is also given in the form of some ranges, and f of x comma y is equal to 0 otherwise. Find the value of the constant c. What we have to find, we know that it is a two-dimensional random variable, right? So double summation value, which is equal to always equal to 1. So using that formula, we get the answer 1 by 42. Likewise, we have to find the formula for expected value of x, expected value of y, expected value of xy, expected value of x square, y square, and the variance of all the things. And finally, we have to find the correlation coefficient of the double random variables. All the answers are given below. Just find the values and substitute in this formula and check the answers. Next, the joint probability density function of two-dimensional random variable is given. Here, find the correlation coefficient. Note that it is a continuous case. So, first we have to calculate f of x. So, f of x means it is a single f of x for only one random variable, right? So, f of x comma y into dy. Substitute the given function. So, here x and y varies from 0 to 1. So we have to substitute these in limits. Finally, after integrating, we get x plus 1 by 2. Likewise, we have to find the value for f of y. It is equal to y plus 1 by 2 after taking the integration. Next, we have to find the e of x, e of y, and e of x y. These are continuous not variables, so we will take the integration. And e of xy means two-dimensional random variable. We have to take the double integration. Within the double integration, we have to multiply xy into f of x comma into dx into dy. So expected value of xy is final answer is 1 by 3. Next, we have to find the variance of x and variance of y. Both the values are given here. Finally, we have to substitute in all the known values in the correlation coefficient. The final answer is minus 1 by 11. Next, the random variable having a joint density function is given here. Find the constant c and the expected values. Yeah. This is for your practice. For finding c, we have to take the integration for this function, which is always equal to 1. We know that the probability equal to 1 times. So we have to use that formula to find the c value. After that, we have to proceed further. Because it is a continuous way of taking the integration to find the correlation coefficient. Next, the correlation coefficient formula is given. Covariance of x comma y divided by x, y into sigma y. This covariance, which is the another formula, that is equal to summation xy by n minus x bar into y bar. So sigma s is the root of summation xy by n minus x bar the whole square. Sigma y is root of summation y square by n minus y bar the square. We have to use this formula also. Compute the correlation coefficient using the following data. So this is x data, this is y data. X and y is given. Here, capital X is equal to X minus 58. In this case, we have to take any rounded value because this is a large value, right? So here we have to replace it for small values. So we have to take any common term. So I am choosing 58. So in every X value, we have to minus that 58. So these values are reduced to a single digit. So the final answer for this X and Y values and the final answer for these X and Y values both are same. So we have to find summation X, summation Y, summation X Y, and summation X square and summation Y square. Next, X bar is equal to summation X by N and Y bar is equal to summation Y by N. So after calculating this, we have to substitute in the covariance formula, standard deviations formula, and finally we get the correlation coefficient answer. Because when we have used it, means the X and Y values are very larger, means we have to use this formula to reduce it for smaller number. Finally substituting this correlation coefficient equation. So the correlation coefficient of X and Y using that above table and substitute the known values, the final answer is 0.6032. It lies between -1 and +1. Next, this problem is for your practice. The numbers are double digits, right? So you have to pick any number and subtract the number from X in all the values of X. So it will be reduced to a single digit number, and after that proceed further to find the correlation coefficient. Thank you.